All right, hello again, everybody. This is Jeff Scott, formerly of Rankin Technical College. And in my YouTube channel right here, or on my channel, JPS, Jeff Teaches Programming, I have been going through or starting to try to teach people Python programming language. Now, good news, bad news type of thing about this. All right, let me tell you what I'm talking about. All right, let's see. So far, we've done an introduction to Python. Talk about what it is, why it's popular. You learn how to install it from python.org. And we talked a little bit more even than I planned on about the editor that I'm using, which is VS Code. All right, we did write a simple program. And today I want to talk about the Python keywords. This may be one lecture, it may be a couple lectures. I have absolutely no idea. But I'm taking this from an article that is out on medium.com. Now, it doesn't say, it does say member-only stories, so you probably can't get to this. But it is right here. All right, I'll leave that up there literally for 30 seconds or so while I talk about this. There are approximately, if not exactly, 38 different Python keywords that you can see on the screen right here. And I'm going to go through all of them. Now, I do want to mention something to you, and that is I went and grabbed this information from here and stuck it into a text file. And I'm going to go back and forth between that. It's going to look kind of unprofessional. All right, and it is kind of unprofessional. But I have 3 laptops. One of them has gone out to pasture, so to speak. I don't know if it's fixable, okay? And it had some of my information on it. Another one is the one that I'm using right now. And the last one is one that I bought a couple weeks ago that I've got to go and move everything over to, etc. But I haven't done so yet. So I'm going to bounce back and forth on here. And again, I do want to go through these. And I want to do these in the construct of where hopefully at least we're going to learn something. And what do I mean? If you don't understand what I just said, I'm going to start with this program that we had kind of worked on before. Now, I'm going to get rid of this message equal roll the dice, roll the dice. I don't care. All right. And I'm going to come in here and I'm going to create 2 numbers. And I'm going to say number 1 equals, and oops, number 1 equals, and basically I'm going to have it be equal to a random number. And we'll just pick 1 and 100. All right, and I'm going to copy this down. And number 2 is also going to be equal to a random number between 1 and 100. All right. Now, when I end up calling this stuff down here, I will now come in and put in, I'm going to replace each one of these with number 1 and number 2. And if you give me about 30 seconds to copy this over, I'm going to explain to you exactly what I'm doing. All right. Now, we brought in NumPy, and this is a keyword that we're going to talk about in just a bit, the as keyword. But right here, we're going to come in and we're going to create 2 variables. Okay. Each is a random number between 1 and 100. Alrighty. Should be pretty obvious. All right. And then I'm going to come in and I'm going to have, really there's about 7 operations, 7 numeric operations that you can use in Python. Addition, subtraction, multiplication, regular division. All right. And I'm going to, so that is what, 1, 2, 3, 4. And I'm going to come up with a few more here. All right. All right. So the first one, instead of divide 2, this one is going to be int divide, is what I'm going to call this, int divide. All right, not divide 2, but int divide. And I'm going to change around the sign like this. All right. Now, when you look at this, what has it got here? It's giving me an error. And it says statements must be separated by new lines, semicolon, invalid character. It doesn't like that, which is interesting. All right. So for now, at least, I'm going to comment that one out. All right. This is going to be mod 2. All right. Like that. Now with this one, probably getting that error because of this line is not commented out as well. There we go. And finally, we're going to have def. We're going to call this expo 2, n1, n2. Now, this could end up being a really big number, but that's okay. So return n1, n2. All right. So let's take a couple minutes and look through this. The first thing I want to do is fix my error that I had in here. So let's see, Python integer divide operator. It says here that it's integer division if the inputs are integers. All right, 7, 2, 3. All right. Well, this isn't working exactly the way I want, but it's okay. It really and truly is. So let's just talk about what we've got in here. For now, at least, I'm going to forget this one. Hopefully, at least, these all make sense. This is going to be, n1 is going to be number 1. n2 is going to be number 2. All right, so when I call this, I'm going to add those two. When I call this, I'm going to subtract the 2. When I call this, I'm going to multiply one by the other. Here will be a divide. Here will be a modulo, which is the remainder operator. And here will be an exponentiation. All right. And that might end up being a real huge number. Like if I had 37 there and 50, it's going to be 37 raised to the 50th power. Could end up being a little hinky, but we'll see in just a minute. All right. Then I'm calling the add, the subtract, the multiply, the divide. And then we will call the mod and the expo. All right. Oh, that's expo 2. Okay. Now, there's much better ways of doing this, but I'm just trying to get a look and feel to see if this is going to work. So let's come in here and do a file, save all. Whoops. All right. And I'm going to put in here print the first number. The first number is. Now, if I try to come in here and say number 1, I'm going to get an error. And the reason that I'm going to get an error, well, I thought I would get an error, is that I didn't think it would like this. But if I come in here, I should be able to say that. All right, which is the string equivalent. All right, so what doesn't it like? Python was not closed. Well, there's the beginning. I don't know, there's the end. Boy, great start, huh? Well, let's just comment this out for now. All right, let's see if we can get these to work. So I'm going to run this, and it may blow up if I get too big a number in my exponentiation. All right, so 49, 15, 544, this, this, and then look at that number. I guess it didn't blow up. All right. All right. So I want to take this. I want to clear all this here. Well, it's not clearing it, but that's all right. All right. Let's take a look at what we've got in here. So we've got in here, maybe it's because I had an X. I don't know. It's still the same. This was not closed. Thought it was str like that. Maybe it's str like this. I don't really remember. All right, there we go. So the first number is, and the second number is. Okay, and that'll be number 2. So let's see if it looks like it's working. All right. Again, I might get some god-awful number, and that is just fine. So the first number is 21. The second one is 54. Adding 21 and 54, 21 minus 54, 21 times 54, 21 divided by 54, 21 modulo 54, and 21 raised to the 54th power. Right now, it appears as though everything we're doing is working. I want to say that again. Right now, it appears as though everything that we're doing in here, it appears as though it's all working. Okay? All right. So let's go back and look at this. And why am I even doing this with you? All right. Well, the first word that we have in here is def. Allows us to write our own functions. So I'm defining, in this case, add to. So it's def followed by the name of the function. Then a parenthesized list, which can be empty if there's no arguments or parameters passed in. In this case, I'm passing in 2 numbers. A colon, and then the body. And a key thing about working with Python is using tabs. All right, now that I've got the tab there, and it's okay. Because the tab is, I think it's by default, it'll be set up to 2 spaces. But everything has to be tabbed over. So our first keyword is def, which allows us to define a function. And when you look in here, we have defined, let me bring this down. We have defined 1, 2, 3, 4, 5, which we didn't use, 6, 7 different functions. Each one of those functions, all it does is it takes the first number and it does the operation followed by the second number. And it returns the result. So what you can see in here is we've discussed now def and also return. And I've also showed you how to call that function. All right. So that's our first couple, I believe. When we take a look in here, I've now talked about def and return. Okay. All right, then let's move on. The next one is yield. A little different in here. It says the yield keyword signifies the output of our function too. But unlike the return statement, stuff can still run after yield runs, which means that our function can have multiple outputs. All right. So it says using yield in a function makes it what's called a generator function, which means that it can have multiple outputs. And we need to use a for loop or some other kind of loop in order to be able to work with it. Now, there's going to be a few things in here I'm not going to go over right now. I promise I will go over yield with you. But I don't want to do it now because my goal is to go over the ones in here out of these 38 that pretty much should make sense to most people. And then we'll go back and we'll look at the other ones. This is another one, lambda. All right, and a lambda function typically is a function that is not given a name. So it's known as an anonymous function. What a lambda typically will do is it'll allow you to take your code and make it smaller than it would be otherwise. So I'm going to make a list here, and I'm going to put in here everything I'm not talking about now. So we had yield, and now, and now we'll have lambda. All right. So we've discussed two, and two of them I've just glazed over. The next one is none. As it says, it represents nothing. So if you come in here and notice we defined a function called hello. That's the name of the function. That's the string we wanted to print. So if you say x equal hello, all right, like that, and you tell it to print x, it's going to return nothing. All right. To say this, x equal hello, let's try this. See if indeed it does come up with nothing. All right. So at the end of the routine that I currently have, of the program I currently have right here, let's put this in. So def hello, print hello, x equal hello. So we've got that before all of these. So for right now, I'm going to take all of these and I'm going to comment them out. So I'm going to comment out each one. Now there's other ways of doing some of the stuff that I'm showing you. I'm trying to be what I consider to be as straightforward as possible right now. I want to see if this prints out none or nothing. All right, notice it printed out none. All right, so we said here x equal hello. Okay, that is going to call the routine and it should print out hello. All right, but it says if we don't return anything in a function, which we're not, we're printing it, we're not returning anything. Nothing is being returned to x. So what it gets returned by default is the word none. So here's hello, that's in the function itself. But since nothing was returned, we get the word none there. All right. The next one is with. Now, in the examples that they show here, they're working with files, which we can do. But that's something that we're going to have to hold off on, at least for a bit. So I'm going to add with to our list of things that we're not going to go over right now. So when you look at what we're going over in here, 1, 2, 3, 4, 5, 6, I've gone over def, I've gone over return, and I've gone over none. I've skipped yield, lambda, and with. All right, we're not going to skip that many, but there'll be a few others in here that we'll skip as well. All right, so let's jump back into our program here. I don't think we really need in here this thing. Okay, so I'm just going to take all of this and I'm going to comment it out. You'll notice when I do that, I get an error here because I'm calling hello, which no longer technically exists. And when I comment this out, I get an error here. That's actually to be expected. Oops, put a P there. All right, so let's continue on. Then the next one is as, and I believe we've looked at that a little bit already. as can be used as, no pun intended, an alias. All right, so in this example, we're opening a file that's called a.text, but when we work with it, it's now called f. So rather than have to give it this name, we can give it that name. Now, is there that big of a savings here? The answer is no. But imagine that we had a big path to this file. All right, some directory slash, some directory slash, etc. And we gave it an alias of f. Now f would represent the entire thing. The other thing we've used already in here, this is what we did. We did an import where we imported NumPy as NP, and we just called it NP. So when we want to refer to it, we can just use NP. Do we have to do that? No, but it's a common practice. Next, we've got import, which goes right along with what we've just talked about. Import allows you to take one or more, you can import libraries and modules into code. Here's some examples. As it says, it's very useful, as there are many Python libraries that enable us to do lots of cool stuff. This is from the author. You can also just import parts of libraries that you need. All right, so as it says, the from part here says the from keyword allows you to import a specific part of a module, basically, instead of the entire module itself. We're going to look at all these as we go on. Please take my word for it. All right. Next, we've got del. And the del keyword, as it says, allows us to delete things in our code. So we've got here a equal 4, b equal 5, del b. So if you try to print b now, you get an error because it doesn't exist anymore. You deleted it. Here, I don't really want to go into this right now, but we're basically going into, all right, a key value pair. Apple's got a value of 4, orange 5, pear 6, and we remove apple. Since we removed apple, when we try to print out D again, we only get this. And again, this is stuff that you're going to see later. I'm not trying to confuse you in here. All right, true and false. All right, one of the different types of variables that you have available to you in the Python programming language is a Boolean variable. Boolean variables can have only one of two values, true or false. Notice they are case sensitive. True is with a capital T, false is with a capital F. All right. Now, you don't have to do this, but quite often when you use these kind of variables, you'll have something like this. All right, I'm just going to keep adding to this. Okay, so I'm going to come in here and I'm going to add another variable. And I'm going to call, let's see, is married. And I'm going to set that equal to true. All right, then I'm going to have an is divorced. And I'm going to set that equal to false. All right. Now, all this other stuff here has been commented out, so none of that's going to print. So if I come through here and say, all right, and this is something we're going to get to in just a minute with if statements, but I'll say if is married. All right, so if is married, print the individual is married. All right. Else, print the individual is not married. All right, hopefully that all makes sense. All right, we can do the same thing with divorced. Let's take this one for now and let's just leave it off. Now let's run this, and since is married is true, it should come in and say the individual is married when we run the program. The individual is married. There it is. If we go in and change this from true to false, and we run the program again, we get the individual is not married. Those are Boolean variables in a nutshell. All right. Now, you don't have to start one with the word is, but quite often you use words like this. I'm trying to impress upon you that when we're doing this, it's kind of nice to come up with variable names, and is married is known as a variable. And all that means is it's a location in memory whose value can vary. All right. All right, let's keep going on here. So we've now done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. And let's go on. So we've got and, or, and not. And let me quickly go over these with you like this. Okay. All right. I'm going to just draw my own thing out here. And I'm going to make another thing right here. All right. And just imagine that I did this. I can write this in fact, let's write it in the program. I guess we can. All right. So we've got all this. Now I'm going to comment this stuff out. All right. Oops. Okay. In fact, I'll comment this one out too. All right. So you see what we've done so far. Okay. Let's just go on. I'm going to come in here and I'm going to do this. I'm going to say, well, I used number 1 and number 2 already. So let's say first number equals 12. Second number equals 25. Third number equals 18. Those are all made up. There's no significance to any of these. But what I want to be able to do with you is to quickly talk about and or, and not. All right? So if I come through here and say, if first number greater than 10 and second number less than 100, okay, so if that's the case, print both conditions met. Else print 1 or both conditions not met. All right, let's be consistent here. Now, take a look at, before we run this, is first number greater than 10? Yes, it is. Is second number less than 100? Yes, it is. We're not even using third number. Okay? Since both of these conditions are met, it should come up in print between the two of these, both conditions met. Let's see if indeed it does. Both conditions met. All right. Now let's change this so that instead of saying less than 100, it says greater than 100. So the first number is greater than 10, but the second number is not greater than 100. So what should happen is it should come up and have this one or both conditions not met. There it is. One or both conditions not met. So when you use the word and this is what I was going to show you before. I'll bring it up right here. All right. So imagine you've got X. I don't care what X is. It's something. You can be measuring something against something else, and there's Y. And then this is going to be the result. All right. So when you use and, if X is true and Y is true, the result is true. But if X is true and Y is false, the result is false. If X is false and Y is true, the result is false. And if X is false and Y is false, the result is false. So what the heck does all this mean? Well, X, in our case, is first number greater than 10, and Y is second number greater than 100. So what you saw was when we said this, less than 100, less than 100, when we had that, all right, then it's true that first number was greater than 10. It's true that second number was less than 100, so our result was true. But if any of the rest of these take place, so with an and, all right, we'll just put in here and, okay? The only time the whole thing is true is if every part of what you're checking is true. If any part that's in here is false, the whole thing is false. All right? What if we change that from and to or? In fact, let's grab all this. And let's paste this in. Now we're going to change this from and to or. And let's see how our table here changes. With or, only one or both true means true. So with an or, the only time it's false is if both sides of the equation are false. So if I come through here, let's grab everything we just put in here. All right, and we'll take the first one that we put in, and we'll comment all of this out. Oops. And I'm going to change this from and to or. And what you'll notice when we look here, this is true. So it doesn't even check this one. It goes through what's called short circuit evaluations. What that means is, for example, on this one right here, is first number greater than 10? Yes. So it must check both of these conditions. And then it finds out with the second one being false, the whole thing is false. However, if the first one was false, if this one is false and you're doing an and, it doesn't have to check the second one. Since they both have to be true and you've already ascertained that one is false, you can just stop. And in the same way, in here, since this one was true, we don't have to check this one. So only if both of these conditions are false with an or, okay, this should say one or both conditions not met. Okay, and there you got it. Because both sides were false. All right. Now, that is and that is or. And there's another one, oops, that's called not. Not is known as an inverter. So we've looked at and, we've looked at or. Let's just come up here and we'll use not. When you come in and you work with not, like I said, it's an inverter. Let's see what they used here. Or not simply switches true and false. So in other words, when you're working with not, all right. Now, when we looked at this one, let's go back and we'll look at both these. All right, is first number greater than 10? Yes. Is second number less than 100? Yes. So it comes back and it says both conditions met. There it is. All right. If we put in front of this not, it should take that true that we had and change it to false. One or both conditions not met. So not is an inverter. It takes a true result and makes it false. It takes a false result and makes it true. All right. Now, when you use these, I'm giving you very, very, very simple examples. You can use all of these together in the same condition. You can use nots, you can use ands, and you can use ors. All right. When you use them, the order in which these things are going to be executed is it goes from the most restrictive to the least restrictive. So your not condition, NOT, is the most restrictive. So the not, one or more nots, will be done first. Then the next most restrictive is and. So ands will be done second. And the least restrictive are ors. So they'll be done third. You can always change that around by using parentheses. All right. So in a nutshell, very quickly, what I just explained to you was not and or. So looking at our list, all right, we've now done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, let's go to if, elif, and else. We're going to look at all three of these together. All right, and that'll give us what? 15, 16, 17, 18 right there. Okay, and we'll look at type and then we'll take a break. All right, so what if I did this? What if I wrote a program and said, and if I wanted to know whether or not this, let's use third number. So I'm going to say here, this will be now third number. So third number is going to give me a random number, and I'm going to use the one between 0 and 100. Okay? And I'm going to say here, if third number modulo 2 equals 0, all right, I'm going to do this. I'm going to say print the number is even. All right. Don't need that, of course. Okay. So let's run it. If we get a number here a random number that's even, then it'll be evenly divisible by 2. And it should say the number is even. So if we get this, okay, and if it doesn't show, what does that mean? That means that we had an odd number. Let's run it again. The number 24 is even. Okay? Now, I could come in here and do this. Come in and say, else. All right, the number is odd. We're going to change this in just a minute. So now one of these must print. So if the number is evenly divisible by 2, it's going to say the number is even. Otherwise, it's going to say the number is odd. The number 94 is even. The number 84 is even. The number 17 is odd. All right? Now, totally fine. Nothing wrong with what I've done. But what about 0? All right? 0 technically is neither odd nor even. All right? So I'm going to come in here and I'm going to change this around. And I'm going to say this. And don't worry, I'll get an error, but I'll fix it right away. So if third number is equal to 0, then I want to print 0 is neither odd nor even. And you'll see that after I did that, it didn't give me an error here, but it's like it doesn't understand. So if I try to put all that together, I want all these together. And right now, this is one thing by itself, and this is another thing. Now, in most other languages, you write in here, else if. Notice it doesn't like that. In this language, you use elif. So if we're generating a number here, if the number we generate is 0, we're going to say 0 is neither odd nor even. If it's not 0, we're going to take the number and divide it by 2. If it comes out with no remainder, we're going to say the number is even. And if it has a remainder of 1, we're going to say the number is odd. Just to make sure we can get this to work, let's go back and reassign. So we'll say here third number equals 0. Now it should come back and say 0 is neither odd nor even. 0 is neither odd nor even. All right? If I come through here and change that from 0 to 10, it comes back and says the number 10 is even. If I change it to 11, it says the number 11 is odd. All right, so what this allows you to do is it allows you to work with selection. If this is true, do this. Otherwise, if this is true, do this. Otherwise, do this. Now, you can have an if with no elif and no else. If the if is true, it'll do something. If the if is false, you'll do nothing. You can have an if with one or more elifs, as many as you want or need, without an else. All right? Then it'll keep checking, and once it finds a match, it'll skip the rest. But most people, when they put in something like this, will put an else at the bottom, which is a catch-all. So I could have as many elifs in here as we needed. All right? So that's using if and elif and else. All right? All right. Jumping back here then, we've now done 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18. Let's do type. We're going to skip class for now, and then I'm going to take a break. All right, so type. Again, I'm just going to jump down into my notes. The type keyword allows us to get the data type of a variable. All right, so let's do this. I'm going to create a bunch of variables here purposely. All right, so I'll come back up to here. And I'm going to say first equal 1, second equal hello, third equal 3.14, 16, fourth equals true. Okay? All right. Now I'm going to print the type of each one of these. So print type of first. Okay. And I think I can do it like this. We'll find out. The type of first is, I said I think that'll all work. So the type of first is, the type of second is, the type of third is, and the type of fourth is, and of course these will have to be changed to second, third, and fourth. Now if I did all this right, it'll say the type of first is int or integer, the type of second is string or str, type of third is float or doubled or something like that, and the type of fourth is bool or boolean. So let's see. Well, it doesn't like what I did, and that's okay. We'll fix it. Can only concat str not type. Well, let's see if we do this. str like that. Okay, I think it'll take that. We'll see in just a minute. And I need to add, well, it added ending parens on there for me. So let's try it again. Still didn't like it. Type of second is, well, let's just remove all this. And we'll type in here, type first, type second, so type first, type second, type third, and type fourth. Okay, like that. Let's run that and see if it runs. All right, so we've got in here int, which is this one, str for string, which is this one, float, which means it's a number that can contain decimal for that one, and bool, meaning true or false for that one. All right, so what I've done so far is I've gone over, other than 3 of them, all right, and I'm going to skip for now class because it has to do with object-oriented programming. So we're going to add that one to our list up here. So that's class. So out of the first half of these, the first 19, I guess really the first 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 20. All right, so out of these first 20 that are in here, I went over 17. All right. All right. So time-wise, I'm at 50 minutes. What I think I'll do is I'm going to take this right now, and I'm going to take a pause in here. All right, come back and do this, and it'll be out by sometime tomorrow. Okay, so I'm just going to pause right now.